According to a recent mobile malware statistics from Kaspersky, there were over 3.5 million installations of malicious packages in 2019 alone. We all know that as technology advances, mobile phones are becoming more affordable, and the number of users continue to grow at a rapid rate. But along with the advancements that are coming with this increasing use, there is a threat. The popularity of Android mobile phone users has given a rise to the threat of security and privacy. After the application gets accepted in the Play Store during its screening test, a lot of malicious variants remain hidden because of their difficulty to get detected. In such circumstances, users discover that the applications contain malware after it has been installed and executed. As a result, it might be too late to undo the malware's damage. Therefore, in this research, we have come out with a working idea of a real-time Android malware detection system that will help us to swiftly analyze Android applications. It will detect malware in real time that is difficult to distinguish, and this is basically our idea behind ShielDroid. So, hello there. I am Ahmedanur Rain, and I will be introducing the motivation behind our research and briefly review some of the related works. Here, we went for a hybrid approach for detecting Android malware. We observed the dataset, extracted the suitable features, and went for different neural network models and classification algorithms. Later, through quantitative analysis, we found out that the approach that resulted in the best accuracy. We also assembled an app using the findings of our research that also comes with a recommendation feature, which can come in very handy for people who are not quite familiar with technology and Android security. During our research, we found out several works that managed to work as a great motivation for us. The research paper Machine Learning and Deep Learning Methods for Cybersecurity describes some of the most widely used network datasets in ML and DL and discusses the three types of intrusion detection systems available, which are the signature based or misuse based, anomaly based, and the hybrid. A recent research conducted in 2017 suggests detecting malicious application based on the application's permission request and API call frequency distribution. According to another study in 2019, a hybrid model incorporating deep encoder and a convolutional neural network was introduced to improve the accuracy and efficiency of Android virus detection. The dataset that we worked on had a preceding exploration, which is titled as Dynamic Android Malware Category Classification using Semi-Supervised Learning. Their analysis managed to get an accuracy of 97.84% in a training time of 16.5 minutes using level propagation, which we managed to triumph by doing it only in 22.945 seconds with a similar accuracy of 97.5%. And that was all from me. Thank you.
Hello, my name is Zarin Tasnim Biash, and I will be covering about the details of our dataset, as well as how we performed data preprocessing and feature selection. The dataset that has been used for this work is the CIC Meldroid 2020. The target of this research is to develop a malware detection system for Android applications which will be efficient enough to detect malware in real time. CopperDroid, a VMI-based dynamic analyzer, was used to dynamically analyze the data in order to automatically recreate low-level OS-specific and high-level Android-specific behaviors of Android samples. The outputs of the analyzer were then used to build the dataset. The dataset consists of 11,598 samples in total, and it is divided into 5 distinct categories, which are adware, banking malware, SMS malware, riskware, and benign. This is the frequency distribution of our label class. Moreover, the study comprised dynamically observed behaviors, which were split into 3 categories: system calls, binder calls, and composite behaviors. Now, moving on to the data preprocessing section, we all know that it is essential in any data mining process, since it has a direct impact on the project's success rate. It minimizes the complexity of the data and improves quality of result. The data is considered unclean if it contains missing values, noise or outliers, as well as duplicate or incorrect data. If any of these are present, the quality of the results will degrade. This is exactly why data preprocessing is performed. We performed data preprocessing through standardization. Standardization is a process of standardizing a group of values for determining how far apart they are from their average value. If the variance of a feature in orders of magnitude is larger than the variance of other features in the dataset, that feature may dominate the others. This will ultimately prevent the estimator from learning from other features correctly. Our learner may place a higher value on features with high variance, which is not desired in the model. Thus, standardization is done to scale the data values inside a certain range, and we performed it for the model by calling the standard scaler method using sklearn. Now, the presence of noisy data, such as incorrect characters and blank spaces in a dataset, can have major impact, leading to a dramatically decreasing accuracy and poor prediction. For this, we screened the data from our dataset and found no noise. Hence, no noisy data removal technique has been performed. When building a predictive model, feature selection is a process of reducing the number of input variables. It is done to minimize the computational time and cost in order to improve the overall model. Feature selection also helps to decrease overfitting, thus improving modeling accuracy. It also cuts down on training time as algorithms may learn faster with less data. Two methods were considered for extracting 120 features out of 470 from the dataset. One of the methods was correlation-based feature selection using Weka, and the other was feature selection according to the k-high scores via select k-best function from sklearn. That was all for this section. The following slides will be about the discussion of our proposed model.
Assalamu alaikum. I am Arman Hussain. We are proposing a hybrid method for our machine learning classification. Initially, we used random forest classifier to generate a predicted column by constructing numerous decision trees. After that, initial predicted column is utilized as an extra input to train a feed-forward neural network. We divided the dataset into train and test in 80-20 ratio. Then random forest is used to generate a prediction for each samples. In our classifier, the number of estimators or trees in the forest was 100, and we used 120 features. After training the classifier with this configuration, we get a prediction column. After that, we use the previous 120 features and one additional column to pass into our deep neural network model. It has 4 hidden layers, each having 256, 128, 64, 32 neurons consecutively with a rectified linear unit ReLU. Nonlinear activation functions cannot be utilized in networks with numerous layers due to the vanishing gradient problem. As a result, rectified linear activation is utilized as the default activation function for MLP and CNN. The ReLU therefore fixes the vanishing gradient problem. The output layer consists of 5 neurons having a softmax activation function for classifying the 5 samples in 5 different classes. The probability of each class is given in the output layer. The highest probability will be considered to be our prediction class. Batch size of 200 was considered for stochastic optimizer. The starting learning rate was 0.001 and it was maintained throughout the process. The learning rate controls and updates the weights. 200 epochs were also used while training the model.
Hello, I am Abu Rehan Shakil. In this section, I will be discussing about our experimentation, results and comparative analysis with the rest of the algorithms we apply. In order to run all the models, Google Colab has been used. After visualizing the data, we use feature selection using Weka and sklearn. The dataset has been divided into train and test data in an 80:20 ratio. Then a random forest classifier was used to generate a prediction for each sample. The predicted column is used as an additional input to train a feed-forward neural network. 200 epochs were used while training this model. The overall accuracy is 97.5% with a training time of 22.945 seconds, which is suitable to implement in real time. In our purpose method, the accuracy for adware class is 97%, banking class is 96%, actual SMS is 99%, which is the highest. XOR class is 96% and winning class is 97%. The confusion matrix is given here. The precision values is highest for SMS and XY classes. The precision recall and F1 score values are all 90% above for all the classes. The recall and F1 score has got the highest values for the SMS classes. The macro average value of precision is 0.98, recall is 0.97 and F1 score is 0.97. From this slide we can see the comparative analysis among all the algorithms we used on our dataset. We can see random forest plus MLP, which is our purpose method, gave an accuracy of 0.98, random forest alone gave an accuracy of 0.94, NAP bias 0.53, SBM 0.45, KNN 0.84, MLP alone gave an accuracy of 0.93. From this we can easily see that our purpose method gave an best accuracy compared to the rest. Random forest help to reduce the overall error, allowing the larger classes to have a lower error rate. On the other hand, MLP is ideal for similar classification tasks and helps with nonlinear and complex situations. Finally, the proposed hybrid learning combining random forest and MLP help in obtaining all these advantages and allowed to achieve high performance with higher accuracy and less computational error.
Hello, my name is Faisal Ahmed, and in this part of the presentation, I'll be talking about the real-time implementation of our work. It was a challenge to implement the detection of Android malware in real time. To overcome this, a client-server model using Flask Web Framework was developed to implement the pretend proposed model. At first, the proposed model was converted into a byte stream using a Python module named Pickle. It allowed us to load the saved model since the program state was maintained across the session. The web server was designed in such a way that if a GET request is sent containing the input data, it returns the calculated probability of that input being malicious and the possible type of malware. Later, the output was used as an API to develop an Android application with an improved UI to detect malware by analyzing the app data. So when our application sends the data using GET request to the server returns the predicted information about the particular sample. If the application is malicious, it shows the type of the malware to the user. It also recommends the user on ways to protect their data and privacy with information about how to recover from it. And if the sample is detected as benign, the application shows a green signal declaring the app is safe to use. We have hosted our Flask Web Framework here in Heroku, which is a Salesforce platform that can run and execute Python programs in a web environment. The result obtained from this web server is used to detect malware from our developed application, which works like a malware scanner for other Android applications. So this is the live demonstration of our work that has been done. The application was built in Java in Android Studio. In the main activity page, we can see there are a bunch of Android applications listed, and when I select one, it sends the app data of the application to the server. After analyzing the app data, it shows whether the application is malicious or not. Here we can see the Facebook application is showing safe and the probability of being safe is 95.64%. If we check another application, which is ICICI Bank increase credit card limit, it shows the application is malware and specific type is banking. And it also there is a recommendation button, and when you click on recommendation, it suggests the user what to do next to protect themselves from this type of malware. If we check another application, let's try the AdFlex. It's detected as adware, and if we click on recommendation button, it shows a completely different recommendation based on the malware it was, and it also shows some tutorial regarding how to block or allow pop-up and redirects on Google Chrome and Android. So that's it. We are almost at the end of our presentation. Apart from all the great results that can be achieved through this proposed model and application, there are still some room for further improvements. We can improve our work in future by making the application more dynamic so that it can work with real and unseen data. Furthermore, the work only detects malware in Android application, which can also be extended for detecting Android malware in applications supported by the iOS platform using proper dataset in the future. So thank you for listening. We sincerely appreciate having the opportunity to present our research work to you.